So, hello everybody. Yeah, so thank you so much for patiently waiting for me. And yeah, looks like we finally go live. Yeah, I mean SpaceX finally start their stream, so I can try this one. And let's go. And I'll enable a little bit setting here the video focus, so it should not distract us from going to stream right now. So, all right, looks pretty beautiful. All right. Yeah. So I think I can go finally. So let's see. Oh, that's not a little bit. Huh? Come on. Where is it? Mm-hmm. Okay, I think I can go. Alright, hello everybody. A little bit weird position there. So, let me reset first. Alright, so hello everybody, this is Dennis Suguwa, and good morning everyone, at least from Sarawak right now, from Borneo. Good morning, and for the rest of the world, wherever you are, have a good day. Yeah, so for today we are going to watch and look at the stream of the Spainsat NG2, which is the Spainsat new generation 2. This one will replace the Spainsat, while previously the Spainsat NG1 actually used for, how do I say, Spainsat NG1 is mostly just to replace the X Star dash EUR, if I remember correctly, satellite, something like that. Yeah, so let's see. This one is obviously the user is the Spanish government and the Spanish Armed Force, which this satellite also operated by the Hisdesat. Basically, a little bit joint venturing between whatever intergovernment, something like that. Even some private, if I believe, if my information is correct. So let's go. All right, looks pretty good. Okay, I've already adjusted the screen here, so this should be good.
Keep climbing faster and more efficiently. At the bottom of the first stage are 9
Yeah,
Merlin engines
and
that propel
so far
Falcon
this
9
is what
off the
we
ground
see right now.
and up to the thinner parts of Earth's atmosphere. The first stage is designed to be reflown with minimal refurbishment between flights.
Yeah.
As mentioned
So
at the
this
top
is
of
the
the show,
situation
due to the
in
additional
Cap
performance
Canaveral
required to deliver today's payload to orbit,
right now.
this will be the 22nd and final flight for the first stage booster supporting this mission. This booster first launched on November 26, 2022, and has since then logged 1,062 days in service. Over the course of its career, it has launched 3 times from Space Launch Complex 39A at Kennedy Space Center, and today will be its 19th launch from Space Launch Complex 40 at Cape Canaveral Space Force Station.
So that's
It has
interesting
returned from
facts that
orbit
we
to
are
Earth
listening right now.
21 times, landing on a drone ship in the ocean 18 times, and on land 3 times. So today we will say farewell to a booster that has served us and our customers well, having launched NASA's CRS-26 cargo resupply mission, OneWeb Launch 16, Intelsat IS-40E, SES-03B mPower-C, Ovzon 3, Eutelsat 26D, Turksat 6A, Maxar 2, SXM-9, and 12 Starlink missions.
So that's
Our
going
payload
to
today,
be
Spainsat NG2,
that's
is
going to
safely
be
enclosed
the
inside
final
of the
flight
17-foot
for this
diameter
particular
payload
booster
fairing,
on the first
which is the
stage.
structure at the very top of the
So
rocket. Made
yeah,
of a carbon composite material, the 2
it's
sides of the
it's going
fairing
to be a
form a
19th
clamshell around the side
flight
to
for
protect
today,
it during ascent.
which is the
The
final
fairing halves
flight
are
ever
then
for this
separated
booster.
at about
So
3.5 minutes into flight,
if I listen
after
properly,
which they will parachute
so yeah.
back to Earth. If recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again.
Yeah, so
The fairing halves
for
supporting
the
today's mission
fairing,
are
looks like
fully
it's going to
with
be
one
used
half flying
again,
for its
and it will
28th
be
time
recovered for
and the other
the
flying
next
for its
mission, just like
16th time.
every SpaceX mission
Below the
nowadays.
fairing, we have the
So
second
that's it.
stage, which
That's
is
it.
the part of the rocket that will take the payload into
Basically,
space
this
today.
is almost as
The
reusable
second
as it
stage will
can
ignite its
be
single
for
Merlin
in
vacuum
its
engine,
current
or MVAC for short,
iteration,
about
which
2
is
minutes and 48
why
seconds per
SpaceX
flight,
already
and will
gone
then
with
relight for a
the
second time before we deploy the Spainsat.
Starship,
With its extended nozzle and optimized
so
design,
they
the MVAC
they
drives
can achieve
maximum performance in
full
the vacuum of space.
how
While the
do I say
countdown continues, let's
full
find out more about
recovery
the
and
satellite
also
that we're delivering to
full
orbit today.
reusability of the
Spainsat
rockets itself.
NG2.
So there are no so they so there are nothing that would be wasted out and can be used. Okay, and see, this is how the Spainsat NG satellite.
With
So
two
let's
new generation
see.
satellites based on Airbus's Eurostar Neo platform, which is developed under the European Space Agency's partnership projects.
So that's it. We
Spainsat
can
NG
use it
program
right
is
now.
under the responsibility of
And of course,
Hisdesat.
I'm using this stream from Space Affairs because if I do, if I directly use the if I because otherwise if I try to use the Twitter stream slash X stream, it's going to be very nuts in terms of in terms of latency. So that's why I use Space Affairs here.
What's unique about the Spainsat NG program is the PASIS 3 funding partnership model.
Yeah, so let's listen into the here, and of course it's going to be used for the X-band, K-band, and also if I remember some payload, let's just say a payload, aka we call this a little bit like secretive stuff side on the of the satellite itself, so we don't know what's the payload going to be for the UHF band, and it's going to be 16 times much more powerful compared to the first iteration of this Spainsat, which was launched on the 16, which was launched on 11 or 12 March 2006. So that's that. So you can listen. This is the example.
The cutting edge of new technology with beam hopping and geolocation
Yeah.
capabilities,
So,
enabling artificial
let's see.
intelligence,
So
big
for-
data, and the Internet of Things on the ground.
Oh, no.
The antennas are being developed by Airbus, which is leading a consortium of 5 Spanish space companies.
Okay. I mean, a bit funny. They're using all of that tech bros buzzword. That's actually a funny one. Even for me, still learning about computer stuff. It's actually funny. Yeah, you can see there are some parts that were censored because
For Spainsat NG1,
Because it's a
mating
little
between
bit
the communication
sensitive,
module and the service
for us, so
module has taken place
it's
in
so
Airbus's
that's why I can say
St.
this is more like a
This was the first
civilian
step
dash
of the final
military satellite.
AIT
So
phase.
it's just like stuff that can be declassified. They just declassified, but for the military stuff, they have to sadly just go blur that out. So you can see that. And for now, maybe I'll get myself. I'll drink. Not get myself. I'll drink my hot choco coffee beverage. So if you don't mind, let me have one. So that's that. That's very simple. And this satellite is in total it will be 6.1 metric tons, aka 6,100 kilograms of total mass, which also going to include the wet mass, aka the mass where propellant will loaded inside of that satellite. Or alright, strong back retract. We have here that for the satellite operational reason, of course. I mean, if there are no propellant, what else can you do? It's going to be uncontrollable satellite, so that's why it does need some propellant and thruster. So yeah, that's all. I'm going to enjoy a little bit of beverage. Let them talk for now. Oh,
And as you
all
heard
right.
there, strong back retract has begun. So watch
Okay,
those arms
strong
to
back
start to open.
has already
The
begun
TE
right now.
does roll the
So
Falcon
that's
9
that.
out to the pad. It also
Just
raises it
enjoy
vertical
the
and
talk
stays connected
for
through the
now.
final seconds to launch. It provides fuel, power, telemetry, and command connections between ground systems and the rocket. We're just about to see those clamp arms start to open around the second stage of the vehicle. Those clamps help to stabilize the second stage during propellant loading, and are also there to prevent movement in high winds. Once they're open, the rocket will be fully free at the top. And there you can see on your screen, those clamp arms have fully opened. The launch tower's strong back is now beginning to move away from Falcon 9, allowing it to stand freely before liftoff. The TE has two components, a strong back alongside Falcon 9 and a launch mount underneath. The launch mount has 4 hold downs that release at
Yum.
T0.
I really
The
like
strong back is
the
hinged
beverage
to that
actually.
launch mount and is rotating
It
about
tastes
2
good.
degrees away from Falcon 9. At liftoff, the strong back will move 45 degrees away to clear the
Oh.
way for Falcon 9's launch.
Okay, and speaking about that, why not we
At this
go
point in
and
the
hop
countdown, both the first and
into
second
the
stages are nearly
NASA
fully
Space
loaded
Flight
with 1
Forum
million pounds of
specifically for
kerosene
this
fuel and
one?
liquid oxygen. The
Why
first
not?
stage
Let's
and
check.
second stage should finish loading
And
liquid
yeah,
oxygen.
I'm going to.
Lock float is complete.
Okay,
And there you
lock
can see
slot. The first stage
has
already
finished LOX
complete.
loading.
Already
Liquid
fully
oxygen
top up
loading for the
the
first
liquid
stage
oxygen on the first
is
stage.
the final
That's that.
propellant load for the booster. The tanks
Okay.
are also pressurized using helium,
So
which is chilled
you cannot see
so that it stays compatible
the
with the
video itself,
cryogenic plumbing.
the stream,
During
but
flight, that
it's fine.
pressurization helps force
Let's
propellant
see
into
what
the
else
engines
is
as the tanks
there.
empty. At
Yeah,
T
so
minus
this
60
is how the
seconds,
satellite
Falcon 9
looks
will enter
like
startup.
in the
At
clean
that point,
room.
the rocket's
Communications
onboard flight
module
computers will
back
take
then
over, and from there on
already
out, the
installed.
countdown will be fully autonomous.
Okay, there's
Just
also
inside of T minus 2
UHF,
seconds,
carbon,
the 9 Merlin 1D engines will ignite,
and also
and once they're at full power,
including
Falcon 9
X-band
will lift
here,
off the pad and begin its
here and
final
there.
orbit. After that
Okay,
engine start, the Falcon vehicles are held
not
down
really
until all
interesting.
vehicle
But this is
systems
the
are
Toulouse
verified as
visit.
functioning normally before
Okay,
we
in France,
release for
you
liftoff.
can see where they are testing. And this is a little bit more picture there, here and there. Okay, and
Stage 2 lock float is complete.
okay, stage
And
2
liquid oxygen for the second
liquid
stage is now fully
oxygen
loaded,
topping
completing prop load before the
already
booster
fully
stage.
top up on the second stage. It looks like ready for the launch, and this is how it looks
You
like.
can see
The
white
range itself for the
condensation
launch,
clouds starting
yeah,
to vent from the
for the
rocket.
safety.
As the liquid
And
oxygen
this is
warms
the
slightly inside
how
the
do I
tanks,
get the
some of
patch
it will
here.
boil off when that gas is vented
So
to
thank you so
manage
much
pressure.
for the
When the vented oxygen hits the warm, humid outside
contributor
air,
here.
it will instantly condense into clouds. Just
And
the
if
same
I
way it's
remember,
always
around T
spread,
plus
but a little more.
33 minutes and 55 seconds, we will see the separation of the Spainsat NG2. So that's that. And the specific booster that they mentioned on the
Stand
first
by
stage,
now for
there will
confirmation
be
that Falcon 9 is in startup
the
at the
use
T-1 minute
one
mark.
is the B1076. Oh, 21, 22. Oh, I guess so because this is expandable. They don't plan to reuse this anymore, so they've already yanked out all of the landing
Falcon 9
leg.
is in startup.
Okay, and
As
the
you just heard,
first stage
Space
Falcon 9
boosters
has
have taken
already
over the launch countdown.
gone
Stages 1
startup,
and 2
already
are
fully
pressurizing
autonomous by now.
pre-launch.
And this is live right now. So now let's go back.
Go for launch.
Okay, and launch director has already confirmed it's going for the
With
launch
that,
itself.
let's listen into the countdown.
And yeah, let's listen into the countdown at just as the commentator says here. And T minus 30 seconds. Alright, already by now already the gas off, or the gas out all of the liquid oxygen from the rocket itself, and T minus 20 seconds. And I'm going to let you guys actually enjoy the flight for the this one, and enjoy everybody. We'll be back again.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
All 9 Merlin 1D engine on the first stage has already ignited, and liftoff! And liftoff from the Cap Canaveral Slick 40, and already initiating the gravity turn for the rocket itself. The first stage has already begun. The pitch, yaw and roll program is in, and we can see all the engines looks pretty nominal and functional.
As you can see, Falcon 9 has
And
lifted off
at least from here, you can see all 9 Merlin 1B engines is already pretty good, and Mach 0.5 by now.
Throttling down engines in preparation for max Q,
Yeah.
maximum aerodynamic pressure.
And
Power and telemetry nominal.
okay, everything is nominal, looks
For
like there,
nominal state of the vehicle.
and should be supersonic by now.
Vehicle is supersonic.
Okay, supersonic, and we'll listen in to the max Q, maximum aerodynamic pressure fully exerted on the launch vehicle itself. Should be by now.
Max Q.
Alright, max Q, slightly a little bit higher on the aeroplane altitude, but it looks pretty good so far. And you can see there's a little bit of the if you see around the pattern of the exhaust itself, a little bit upside there, you can see a little bit of the sound barrier, the sound shock wave compressing the rocket itself, and that's one of the important reasons why before the max Q, all of the first stage engine usually Merlin vacuum engine already start chilling on the second stage there, and that's why usually it would be tuned down to around 60%, if I remember correctly, 60% to ensure the launch vehicle itself did not get full total stress that would destroy the launch vehicle itself. So that's why after the max Q already reaching the maximum aerodynamic pressure on the certain thickness of the atmosphere, including the velocity itself, eventually it will just go tune back in, and we are ready for the stage separation. Okay, by now should be stage separation, and we shall hear the caller of the Merlin engine, main engine cut off number 1, or main engine cut off. You can see it's already thrusting out a little bit slowly, and then it just shut down on the first stage, and stage separation confirmed, and ready for the ignition of the Merlin vacuum engine, and ignition of the Merlin vacuum engine on the second stage. Alright,
And there you heard and saw those events.
and maybe
back to back.
at some of
Stage
this
7
one,
and SES1.
the stiffener
As a
on the
reminder, the first stage will
second
not
stage
be
should have
recovered.
already been
In preparation for this,
should have
remove the landing
should have already
gears and
removed
grid
there.
fins to decrease the mass of the first stage and save them for use on future missions.
Yeah,
Now,
so that's
we
why.
say to the first stage, thank you,
And get ready for the
farewell.
fairing separation here.
Fairing
By now,
separation is next.
it's already
Just a few
passed
seconds.
on the
We will be attempting to retrieve both fairing
Karman line there, already passed
our recovery vessel,
all of it,
Doug.
and get, which is already defined as the internationally recognized as the space boundaries, and get ready for the fairing separation. Okay. Yeah, good view on inside of the fairing camera of the satellite itself, and fairing separation is already confirmed.
And
As we
heard,
can hear it,
separation
fairing separation is already confirmed.
The
And
fairings will orient themselves
did you
to the
notice that the
against
G-force
the
itself
for entry
already
into the atmosphere.
slightly gone higher,
As they near the ocean,
but
each fairing
it starts first around 0.9 G, right? And then it's going to 1.0 G. Basically, the same amount of gravity exerted as if in around the Earth here, the same one when thrusted out up there, and it's just only 10% higher on the second stage here in the G-force, and already 20% higher than the Earth's gravity here. Okay, and looks like that's a little bit of music here by SpaceX, and you can see the velocity has already increased to around 13,000 kilometers per hour. Altitude is 145 kilometers, already gone to 146 kilometers. Okay, 47, 148 right now. Alright, and now G-force has already gone 30% higher than the Earth's gravity, typical Earth's gravity G-force, and you can see there. And the mission elapsed right now is in T plus 5 minutes and 15 seconds, and altitude right now is 155 kilometers, and velocity is 14,700 plus kilometers per hours. And you can see there, and the reason why the exhaust looks pretty pretty orangey, you know. It looks, and also usually if this launch around the daytime there in Cape Canaveral, usually you will also see some black suit there. Because why is that? It's very simple actually, because this entire rocket is actually, how do I say, the fuel itself, the RP-1 rocket propellant 1, basically a very very refined kerosene that removes 99.999% of the impurity, including, if I remember, lead, something like that, was used on this one. So because this is hydrocarbon, of course it's going to compose of carbon, it's also going to compose hydrogen and some, yeah, it's only these two elements that's so complex that when it burns, it would burns with full power, with full energy, density, whatever you want to call it, right? So that's why, and because it does have that carbon element, that's why you see this orange glow there. It's not like fully hydrogen, unless you really want to use liquid hydrogen, which, while it's very good, there are actually some problems there. If you try to use liquid hydrogen, it's going to be very less denser compared to RP-1. So that's why they use this refined kerosene, of course. If I remember, it's almost 10 times lower density compared to this what SpaceX is using right now. But recently, the hydrocarbon one, they actually using recently also using the methane as the hydrocarbon, because let's just say it's slightly simpler to use, but it's not going to produce tons of soot, carbon, whatever is it. So that's why they want to use it, and that's as close as they can get. Super dense. We can say it like the super density of. Alright, and Merlin vacuum engine on the second stage has already cut off. Number one, and by now it should. Okay, orbit insertion has already considered nominal. Okay, coast phase around the ballistic phase right now, so the engine will not ignite for quite some time, until around some point.
We'll see you back here at about T plus 25 minutes.
Okay, so that's what we can actually listen to. Okay, and right now, because we don't have too much things, not much else to do right now, so that's that. We are just going to see it here. And in the meantime, what I want to explain a little bit more. Recently, we also saw some how do I say, some propellant in combination that's in use for the hydrocarbon. Let's say you want that good, the best benefit side of super high efficient liquid hydrogen goodness, but you still want it as dense as it can be, with as little carbon, as little soot, and little maintenance as possible. That's where the liquid methane actually came in. You know, it's like the best compromise of both worlds. You still get the best energy and power density, but at the same time, you also get that almost clean burning color there. Yeah, so that's also a recent switch that we actually saw there. And that's a little bit of music for now. Okay, I've already switched the music to usually what I will use for my channel, because why not? Or maybe I can just say this a little bit in Malay. Sebab boleh dek. I mean, in a bit joking way, manner and possible there. So that's that. You can see on the first stage there, looking pretty good on the fairing, on the firing payload side there, and also second stage there on the second stage engine. Looks like we have at least 3 cameras there, 3 engineering cameras on board that we can actually look around. Okay, and of course most of these will beam to the Starlink and also to the ground station control there, telemetry, so they can keep an eye for this satellite and also the whole rocket as a whole too. And that's why it's very important there, and you can see looks like it's already going out of range a little bit, even maybe possibly even out of range from the Starlink, so that's why we can only just see through this telemetry. And yeah, speaking about which, I think maybe I also can try show a little bit of how it looks like here. Let's see. Yeah, maybe I'll change a little bit, and you might see a little bit blank there because I just opened my PDF just to show you this launch mission, especially the so let's go. Let's change to display mode if this is okay. Okay, so speaking about which, this is how it looks like on the mission side there. This is of course contributed by the member of NASA Space Flight Forum, which converted this to, how do I say, the launch profile, something like that. I don't know how do I properly pronounce this. I have an idea, but I just cannot properly pronounce. I just probably cannot convert this into my word here. So just like here, this is the PDF looks like, and looks like around this is the launch profile. You can see this is the launch, ascent, stage separation. You have already seen even the firing, and the last and important stage would be the payload separation. We are going to see here soon. And this is the launch and deployment timeline. Okay, around all of this has already been done, but the second engine start number 2, we will see around T plus 26 minutes and 51 seconds, and followed by the second engine cut off CCO2 around T plus 27 minutes and 55 seconds, which is 1 minute and 4 seconds of the second stage reignition once more, just to align the satellites to its geostationary transfer orbit there, going to GTO first before eventually going to the geosynchronous Earth orbit, or aka geostationary Earth orbit, basically where the satellite will also going to orbit around the same 24 hours spacing of the Earth, roughly plus minus. And after that, around 8 minutes later, at T plus 35 minutes and 55 seconds, we are going to see the Spainsat NG2 will deployment there, or could be a little bit slightly plus minus, but as long as it's still perfect, almost as perfect as it can be. It could separate a little bit earlier, a little bit late, but it's fine. It's totally fine because all of these rocket variable is pretty complicated. Even I myself sometimes doesn't even have anything to say there. Yeah. So that's that. Yeah, I guess that's all. Oh. Where is it? Yeah, so that's how it looks like. Yeah, and don't worry if you see whatever file path directly there. Usually that's how actually I just go live and obtain some of the important information for this particular flight. I mean, literally everything else. I do have some collections, even past stream I'll do, what usually I will do. But at some point, maybe around next year, maybe, yeah, maybe on the 1st January, or if there are no flight at all around the late December, yeah, around the late December, or maybe if I go somewhere for the Christmas, maybe I'll just back it up again to the back hard drive, and then we'll prepare again for the 2026 edition. So yeah, that's that. And yeah, this as much streaming like this isn't my full isn't really my full time, but I'm really happy. I'm really happy to still have you guys, even just one people here watching right now currently. I'm really happy. I'm very delighted that you guys chose to watch this stream. Yeah, choose to watch my stream, and maybe hear some of my whatever weird yapping here and there. So that's that. Thank you so much. You guys really keep me sane after all of this, all of my own life challenges, which I'm not going to dive in. I prefer not to tell that story for now. That's a little bit private for me. But what's not private is what I'm doing with my channel right now. Yeah, and also of course, credit and shout out to Space Affairs for restream this SpaceX broadcast. Otherwise I will otherwise maybe I cannot stream this much, because let's just say the Twitter/X stream, it's very highly sensitive to latency. Very sensitive to latency. It's not going to be pretty good for my mobile data. So I rather just use this restream instead from Space Affairs. So thank you so much, Space Affairs, for this too. And yeah, if you want, you can also go subscribe to Space Affairs and also to myself. There's Daniel Suguwa here, because why not? I'm going to stream as much as I can, and hopefully even if I got a job someday or got a work. I know job is sometimes people will just lose their mind a little bit. People just say in this economy, but hopefully by the time I do have my job, it's not going to completely how do I say, it's not completely occupy my own thoughts and my own time, so I can continue just doing this. So why not? There is no point for me to just go and quit this channel. There is no point. I cannot do that. I just simply cannot afford it, because this channel, what I have right now, is basically my creative outlet right now. I'm sure it's not going to be the most highest effort, but it doesn't have to be. Yeah, seriously, it doesn't have to be a super high effort channel. But maybe for video side, yeah. But for stream, well, what do you even expect anyways? like if you even see my recent stream, and also even my past stream, it's really not 100% perfect. There's lots of things, variables, this and there can go wrong, but eventually I just keep pressing on it, keep doing whatever smart things to do. Yes, that's how I still can keep maintaining this channel, in some ways and others. So that's that. And yeah, for this one viewer, if you really have a question, please ask question here. I really want to see on the live chat, because it's a little bit sad if I don't have anything to say. I'll just yelling out of nothing. Okay. That's a little bit enough of joke. But yeah, I'll try to answer your question as much as I can, if you guys really have one. Oh, wow. Yeah. Wow. What's even happening? Okay. Should be good. Alright. So far, it doesn't even show any drop frames, so fortunately, nothing, no issue related to the upload stuff. I don't know, because mobile data can be hit or miss, unless I'm using Unify, aka using the fiber optic Wi-Fi one. Maybe it's more reliable, but yeah, it sucks. I have since I'm student at the end of the day, and I'm living somewhere else, somewhere in Sarawak. So of course I have to use mobile data. What else I can do? Unless I can go find some something I don't know. But yeah, if you have any question, please ask anyways. It's a little bit boring without you guys here. Alright. And I need to remind you that if I cannot answer your question from the comment section, you need to know it's really not your fault. You know why? Because for whatever reason I cannot actually type in into the chat box here using OBS built-in browser. I don't know why. Maybe YouTube just decided to just just to use that just to phrase this one word, sebab boleh deh. Just because we can. I don't know. This is YouTube. YouTube tends to change everything else. Even what you see right now, even YouTube already changed already changed the layout. I just don't understand. They keep changing things, and sometimes they destroy some things that should not be destroyed. Yeah. So I don't know. It's a bit pain in the ass. So I instead have to go and chat in the and directly directly write my chat here using my phone. If you guys really need to say anything, if you guys really want to talk, so please have a talk. Please chat there. It will be a little bit sad for me. And so far, oh, okay. And so far for you guys, oh, what's it? Oh, looks like. Wait. Do we actually have ignition? Wait, seriously? I need to recheck my PDF here again. Because the altitude looks like increasing. Or not, I don't know. Maybe the telemetry. Yeah, I can confirm there is telemetry is a little bit haywire on live stream there. So I don't know. Just let it be, guys. And yeah, and so far, because we still have one people here, just keep watching mine stuff. Maybe you can give feedback. Maybe you can actually give me a bit feedback. Is it okay? Do my microphone actually sounds better? Because this is a bit recently. I just bought this headset, like not headset. It's more like earphone, like few weeks ago. Yeah, still pretty new, and still got some warranty there. So I want to know, is my voice clear here? No problem, no hissing. Or whatever. Maybe you guys maybe some of you actually pretty shy to even chat anyways. So it's fine, totally understandable. I'm not hosting you guys. So let's chill, okay?
And we're back with live coverage of the Spainsat NG2 mission.
Yeah, so here.
So far, we had an on-time liftoff at 9:30 p.m. Eastern from
And
Space
from
Complex 40 at Cape Canaveral Space Force Station.
And we soon will see the second engine start, number 2,
and the first light
SES2,
or SES1.
around 26 minutes and 51 seconds, and then cut off the Seco second stage engine cut off equal to around 27 minutes and 55 seconds. It will be like around 1 minute and 1 minute and 4 hours of SES1, SES2 ignition.
Geostationary transfer orbit. Now let's wait for those callouts.
Yeah, so we are going to see. Let's hear this call out in less than a minute right now. Let's hear the call out from the ground station from the Houghton, California, and also, if I remember correctly, yeah, from the Houghton in California, if I remember correctly, the location there, where SpaceX also have their mission control center there, and also around the Cape Canaveral Space Force station there too. We'll listen in. 20 seconds left, and we shall hear the second engine number 2 ignition SES-2. 10 seconds. 5, 4, 3, 2, 1. Ignition and reignition again for the second engine is start. Number 2.
This burn will last approximately 67 seconds, typical for a geostationary transfer mission.
Oh, 67 instead. So which means around 1 minute and 7 seconds instead of 1 minute and instead of 1 minute and 4 seconds. But we shall see which one is correct. We see.
As the remaining propellant is burned.
It should be around 27 T plus 27 minutes and 55 seconds. If not,
second engine cutoff.
if not, it could be around almost 20 T plus 28 minutes, which will be around T plus 27 minutes and 59 seconds like that. We shall see soon. Get ready for the Seco-2 second engine cut off number 2. Be prepared. Oops. Okay, and Merlin vacuum engine shut down on the second engine of the second engine shut down number 2.
In just about 2 minutes.
Okay, just a short break, a little bit. It's not going to be that long, and after that I need to chase my boss for just to go study, because why not? I'm an university student at the end of the day, so yeah, I do have like a little bit outside as I've been doing this thing anyway. Okay, I think this is good. Alright, and we will see the Spainsat NG2 deployment at T plus, let me see, refer back from my PDF here, at T plus 35 minutes and 55 seconds, almost T plus 36 seconds, almost T plus 36 minutes, sorry. Let me reiterate again, we shall see the separation and deployment of the Spainsat NG2 at T plus 35 minutes and 55 seconds. Yeah, so I've already cleared this out, just to not get this wrong. Okay, and looks pretty good so far. And for this one person that's still watching my stream, thank you for thank you for keeping me company right now. Even your viewingship actually appreciated. I'm very appreciative your time here. So thank you so much. And for you guys that actually watch this stream live or also in replay, feel free to actually hit the like button and hit the like button of this stream and subscribe to my channel, and also comment whatever you want to comment. As long as it sounds very interesting, I will like your comment, even love, heart, pin. I don't know. If I decide I want to pin, I can. Again, let's see who's going to be very, very lucky to get that pin someday. But for now, even little sufficient. And you can see on my right,
Welcome
on
back
my
to
left
the
side of my
Spainsat
avatar, you can see
NG2 mission.
that's the
We've had a great
map
mission so far,
currently,
and we're now approaching
where
payload
the
deploy for our customer,
where
Hisdesat.
this satellite and
Today's
the
satellite
rocket
will be
itself
placed into a
heading to.
geostationary position
So that's
at
that.
30 degrees west.
It's now
Spainsat
around
NG1, which
around the
SpaceX launched
African
earlier this
territory
year,
area right
and
now.
Spainsat
So yeah.
NG2, this launch, will eventually replace the current Spainsat and X-Star satellites. Hisdesat is a government satellite operator, providing secure satellite services to government agencies in various countries. Hisdesat has provided Earth observation services with radar technology through the PATH satellite, which SpaceX launched on a Falcon 9 back in 2018.
Yeah, so that's
Spainsat NG is a
good.
part of a program developed by Hisdesat to improve secure satellite communications and defense capabilities for the Spanish government and others. Spainsat NG will cover an extensive area that ranges from the United States and South America to the Middle East, Africa, Europe, and Singapore. Now let's hold tight as we come up on payload deploy shortly.
Yeah, so that's that. Oh, and also you can see interesting glow there. Interesting glow lit by the sun itself. Looks pretty interesting. If I have to tell you, it's like the shine beam of the path of heaven. That's kind of stuff there. It looks pretty interesting. Okay, I just open music here because why not? Let's not make it too boring. And then maybe around a minute or 30 seconds so before separation and deployment
If
of
you're just
the
joining us now, we are currently awaiting
the
payload
Spainsat
deploy
NG2,
of the
I will
Spainsat
also going
NG2
to
satellite into geostationary
I'm
transport
going to
orbit.
sign in the music part here. So that's that. We are going to see pretty soon. Around T plus 35 minutes and 55 seconds, we will see deployment of the separation and deployment of the Spainsat NG2. Okay, and still looking good, and you can see beautiful shot of the onboard camera there. Right now facing the second stage engine and also
And we're
the
just now
payload
expecting
itself,
payload deploy
the
in about 1 minute.
Spainsat NG2 satellite there. You can see it's pretty beautiful there. And also another beautiful shot of the glowing sun there. Glowing sun rays beaming beaming to the nozzle to that nozzle there. Almost called nozzle as nozzle. I don't know what's happening with my tongue, with the way I speak. It's pretty blah blah blah. Yeah, you just hear the way I'm speaking. That's me. And looks like we are looks like we are 2 minutes away from separation and deployment of the Spainsat NG2 satellite there. Okay, and be prepared and get ready. Alright, still ready, still anticipating. Alright, and looks like it's separation and also deployment of the Spainsat NG2 satellite. It's already deployed earlier than what I expect, around T plus 34 minutes and how many early seconds there. Looks like separation and deployment of the Spainsat NG2 satellite.
And there you just heard the call out, and you can see the successful
Yeah.
deployment of the Spainsat NG2 satellite as it begins its journey to its destination geostationary orbit.
Yeah.
And with that, we're going to wrap up our coverage for today.
Yeah.
Us at SpaceX want to give a big thank you to our customer, Hisdesat. We also want to give a shout out to the Eastern Range and Federal Aviation Administration for supporting today's launch. If you're interested in more launch coverage, head over to
Yeah, look at that.
SpaceX.com/launches.
It's really beautiful. You can see the Spainsat
When you're
there,
check
and
out
also the
our
sun
trailer
there.
featuring our
It looks
upcoming
pretty
launches and
beautiful
all the
shot
details
there.
you'll need to join us next time. And remember to
Yeah,
follow us
beautiful
at
shot.
SpaceX on X. We'll see you again soon.
Okay, so that's all, everybody. So thank you so much, everyone, for watching, and of course, and also thank you to Space Affairs for also restream this one too. Yeah, so that's all you need to know. It's pretty interesting, isn't it? It's now in the geostation, and now it's in the geo transfer orbit. Yeah, geosynchronous transfer orbit right now, and then it's still checking of the satellite, and then they need to do a little bit of preparation before finally heading to the intended slot of the orbital position itself. It's going to the geostationary of orbit, GO, around 36,000 kilometers of altitude, where it will be positioned to the 30 degrees west there to replace the original Spainsat launched back in the 11 or 12 March 2006 on board the Ariane 5 ECA, the most upgraded version of the Ariane 5 up until its retirement back in 2024, if I remember, or 2023, in launch in Kourou, French Guiana, in the Guiana Space Center. So that's that. That's the only thing we need to know about. So thank you so much for watching. Not much else I need to tell you, because I also do need to chase the bus right now. I need to go to the class. So thank you so much for watching. Take care, everybody, and see you guys for the next stream, which, if I remember, it will be for the HTV-X. Yeah, HTV-X1, the maiden flight of the HTV-X, basically the upgraded version of the original HTV launched by JAXA back in around 2008-2009 like that. So thank you so much for watching. Take care, and we shall see you again soon for that too. Around Sunday, if there is no delay, on 26th of October 2025, or in some places would be 25 October 2025 on Saturday. So that's that. Thank you so much for watching. Oh yeah, thank you so much for watching, and it's a little bit of time off. Okay, so this is Suguwa. I'm your host here, and signing out, everybody. Thank you so much, and take care. Bye bye. And obviously, there is nothing to talk here behind the scene. Everything is done. Goodbye, everybody. Take care.